Hello everyone, so today we meet again. So today the topic is on how to do the computation on the estimation in time, DIT FFT. So if you still remember in our previous lecture, okay, another technique to solve finite length discrete sequence is using fast Fourier transform. So under fast Fourier transform, there is one technique which is called butterfly diagram structure. Okay, so under butterfly diagram structure or FFT itself, we have two sub techniques which is called decimation in time, that's DIT FFT. Another one is decimation in frequency, which is DIF FFT. So today I'm going to show you how to do the calculation on DIT FFT. Alright, so if you read through the question, we have the input signal Sn and the value of the Sn is 2, 2, 2, 1 and the range is from 0 to 3. So first, when you get the question, you have to identify the capital N value. So from this question, you know that your capital N value is 4. So again, how to know your capital N value is 4? It is from the range. Okay, so we have 0, 1, 2, 3. So we have N equal to 4. Next, what you have to do is, you have to know what is the M value. And then you have to determine what is your R value. So M is equal to log 2N. Okay, which is equal to log 4. And this one is equal to 2. So your M is equal to 0 and 1. Okay, after you get the M value, you can determine the R value. So for you to determine the R value, first you list down all your M values. Okay, so at the last stage, you have to use this formula, 0, 1 until N divided by 2 minus 1. So this equation is only valid for the last stage. For N equal to 4, the last stage of N, capital N equal to 4 is 1. So M equal to 1 is your last stage. So definitely you have to use your R equation at M equal to 1. So R equal to N divided by 2. 4 divided by 2 is 2. Minus 1 is 1. Okay, next what you have to do is, you have to bring up for R at M equal to 0, you have to bring up the R value which is at the even position. So in this case, the even position is N equal to 0. Okay, so you bring up the 0 up, so M equal to 0, R equal to 0. Okay, this is for N equal to 4. Alright, so from here you know that N equal to 4 means you have 4 lines. Okay, and you know that your input is Sn. Your output is X capital K. Okay, next. Okay, if you still remember from my lecture, okay, we have initial stage, we have first stage, second stage, and so on. Okay, so for you to know what is your stage, is actually depend on your M. Okay, so first, okay, DIT FFT, the structure is, it must start from many lines to one group. Okay, so we start from many lines. So we have main connector first, and then in between main connector, we have small connector. And then this is our first connector, small connector, and finally our last, our final main connector. Okay, so basically this is our initial stage. This stage is actually at m equal to 0, r equal to 0. This stage is actually at m equal to 1, r equal to 0 and 1. Okay, so the lines, the arrow is from input to output. Okay, next, what we have to do next is we need to connect the lines. Okay, so basically how to connect the lines, it is from input to output again. Alright, so basically when we want to connect the lines, we must connect to the nearest point, the nearest dot. Alright, so this is your initial stage. Okay, next, maybe some of you will ask, okay, how to know how many groups we have to form from many lines to one group. Okay, so what you have to do is, okay, first, as you know that our first initial stage consists of n equal to 4. Okay, if you still remember from our equation, we have n divided by 2. So what we have to do next is we just take this equation, okay, which we implement here. Okay, so basically your next n is 4 divided by 2 equal to 2. So means at m equal to 0, we have, under this structure, we have 2 groups. Okay, and then next, n 2 divided by 2 equal to 1. Where I get 2? This 2 is coming from here. Okay, so 2 divided by 2 equal to 1. Means we are going to form from many lines, from 4 lines, become one big group. Okay, so how to form a group, okay, from many lines to one group. Okay, so I'm going to show you how. Okay, so for the first one, we are going to connect first point. Okay, let's say we have A, B, C, D. So A will connect to point B. Okay, C connect to D. This one, C to D. Okay. Okay, next we connect. Okay, we have now, instead of 4 lines, we have 2 groups. Okay, let's say I name this group as A, this group is B. Okay, next we connect. Okay, instead of 2, okay, now we have 2. We want to form from 2 groups become one big group. Okay, so what we have to do is, for example, we have point A, point B, point A, point B. So point A group A will connect to point A group B. Point B group A will connect to point B group B. Okay, next, point A group B will connect to point A group A. Point B group B will connect to point B group A. Alright? Okay, so, okay, maybe some of you wonder why we have small connector. Okay, this small connector is to avoid confusion when we do the calculation. Okay, so what happened? Okay, this knot is actually our input knot. This dot is actually our output dot. This dot is, okay, so to avoid confusion, we must have this small connector. Alright, okay, so next, what we have to do next is, Okay, so basically from the theory, we know that for DIT FFT, the output, the SK will follow the sequential order. Okay, so when I say sequential order, it is from 0 to 3. So we have X0, X1, X2, and X3. Alright, so for you to get what is your Xn here, you have to do bit reversal. Alright. So how to do bit reversal? You need to convert your decimal number become binary number. Okay, so 0 is 0 0, 1 is 1 0, 2 is 0 1, and 3 is 1 1. Okay, when I say bit reversal, you can imagine in between you have a mirror. Okay, so mirror of 0 0 is 0 0, mirror of 1 0 is 0 1, mirror of 0 1 is 1 0, mirror of 1 1 is 1 1. So 0 0, you convert this one back become decimal number, so you will have 0, 2, 1, and 3. Alright, so next what we are going to do is we need to position, we need to put our week. Okay, so how to know week at which location? So by theory, we know that for DIT FFT, the week, or we call as W and R, must be positioned at input node or dot. Alright, so if you look at this diagram, we have many input nodes, right? We have this one, and this one. Okay, so which input node? This input node must be connect the character. Okay, must connect to arrow pointing upwards and horizontal lines. So this is our input. Okay, so basically we don't have arrow pointing upwards here, right? Okay, only this part and this part. Okay, right? So what we have to do is we need to locate. Okay, arrow pointing upwards means here is our W and R, here is our week. Okay, so here also we have our week, and here also we have our week. Okay, now, okay, instead of you use this condition, you can see from here also M equal to 0, R equal to 0. Okay, means when M equal to 0, our R value is 0, only one value of R. Means this R equal to 0 represent how many weeks you have in one group. So if you look at this group, we have 1 week. If you look at this group, we have only 1 week. But if you look at this group, we have 2 weeks. Okay, how we know that we have 2 weeks? From the R value. So basically, from the R value, you may know how many weeks you have in one group. So from there, we know that the value for this week is W40, and this week also is W40. Okay, maybe some of you may wonder why we put W40 here and then here also W40, not W41. The answer is very easy. Okay, if you look at here, we only have one R value, which is 0. So basically, again, R value represent how many weeks you have in one group. So if you look here, we have 2 groups, and for each group we have 1 week. So definitely we know that for this week the value is W40, and this week is also W40. Okay, same goes to this one. We have two weights. Why? Because of we have 2r value. So because of that, we know that first weight is w for 0. Second weight is w for 1. Alright, so how to know the value of w for 0, w for 1? Okay, from the equation w and r equal to exponent minus j 2 pi and r over capital N. So this one equal to so what you have to do is you just substitute the value, and then if you substitute this value w for 0, it is cos 0. So cos 0 is 1. This one w for 0 1. W for 1 is actually cos 2 pi over 4 minus j sin 2 pi over 4, which is equal to minus j. Okay, next, horizontal lines that connects to the weight. Okay, this line connect to the weight, the value is always minus 1. Horizontal lines that connect to the weights, the value is minus 1. This is the structure. Okay, next, what we are going to do next is we need to calculate the values. Okay, so for you to calculate the values, okay, we have x0, x2, x1, x3. You cannot simply put the values 2, 2, 2, 1, which is totally wrong. So what you have to do is you have to look at the equation, the sequence itself. Okay, this sequence is when n equal to 0, 1, 2, 3. So when n equal to 0, the value is 2. When n equal to 2, the value is 2. When n equal to 1, still the value is 2. When n equal to 3, the value is 1. Okay, this is very coincident. Okay, what happen if we have 1, 2, 3, 4? Then you cannot put 1, 2, 3, 4. You must follow your n. Okay, alright, so now we will do the calculation. Okay, so we want to get the value of this one, this knot. Alright, so 2 times 1 times 1 times 1 is 2 plus, okay, 2 times 1 times 1, your weight times 1 is 2, so equal to 4. Okay, so basically the idea is we have, okay, for example, this is A, B, and then this is C. So C equal to A plus B times W for 0 times minus 1. So you will get C. Okay, so again, 2 times 1, 2 plus 2 times 1, 2 times minus 1 is minus 2. So here is 0. Okay, same goes to here. 2 times 1, 2 plus 1 times 1, 1 times 1, 1 equal to 3. So 2 times 1, 2 plus 1 times 1, 1 times minus 1. So you have minus 1. So here is 1. Okay, next we want to determine what is the value of this dot. Okay, so for, okay, this is from the output. Okay, so you can just bring it to the input. So 4 times 1, 4 plus, okay, you follow the lines. 3 times 1, 3 times 1, 3. So x0 is 7. Okay, next x1, 0 times 1, 0, and then 1 times minus j times 1 minus j. your xk is equal to 7. Just look at your value. 7 minus g, 1g. So 7 minus g, 1 and g. The range is from minus 0 to 3. Done. Now we move to second example. Okay, read the question carefully. Verify the answer of example 1 using DIT FFT. Okay, so if you still remember in example 1, you need to use matrix multiplication, right? To solve, to determine what is GK, what is HK. So, same thing. Okay, we need to validate, we need to verify the answer you get from example 1. Okay, so instead of we use matrix multiplication, we verify using butterfly diagram, which is DIT FFT. Alright, so from the question, we have GN. Right, so from these two sequences, we know that our capital N is equal to 4. Okay, refer to the range. Okay, so from here, after we identify our capital N, next you need to determine your M. So M equal to log 2 N. Okay, so log 2, 4 equal to 2. So your M equal to 0 and 1. Okay, next, after you determine M, you need to determine R. Same thing. Okay, so R at N equal to 0. At the last stage, you need to apply this equation. Okay, so when you substitute the value, you have this one. Okay, next, okay, you need to bring up the value at the even position. So at M equal to 0, R equal to 0. Okay, next what you have to do is the DIT FFT. So basically, we have 4 lines. Okay, and then we have the main connectors, first main connectors, which is our initial stage. Okay, so we have our output xk, and then we have our input. So arrow is pointing from input to output. Alright, so next you may want to know how many groups you have to create. Okay, so basically here is our initial stage. So our initial stage, we have N equal to 4. So for our next stage is N divided by 2. So we have 4 divided by 2 equal to 2 groups. So we have 2 groups. Next, from 2 groups, we need to divide by 2, which is 1 big group. Okay, so now we are going to connect the lines. Again, connect to the nearest dot. Next, from 2 groups become 1 group. Okay, so you connect. Okay, next you know that. Okay, horizontal line. Okay, so basically we have our weight here, and then here also our weight. So we have W40, W40. Here we have W for 0. Here is W for 1. So the horizontal lines that connect to the weight, the value is -1. Horizontal line that connect to the weight, horizontal line connect to the weight. Okay, next we are going to determine the xk. Alright. So for you to determine the xk, you must know the sequential order. So for DITFFT, the output, the sk will follow the sequential order. But for the input, we need to do bit reversal. Okay, so we convert from decimal to binary. So we have like this. Okay, imagine you have a mirror in between. So here we have 0, 0, 0, 1, 1, 0, 1, 1. So from binary, you convert it back to decimal. Alright, so next, oh, not X, it is G. Okay, sorry, it is G. Small g, capital G. So we have capital G, capital G, capital G. This is small g. Okay, sorry for my mistake. Okay, so G0, the value is, okay, here we have 0, 1, 2, 3. So G0 is 1. G2 is 0. G1 is 2. G3 is 1. Okay, next we are going to compute. Okay, so this one, okay, you can just put 1, 0, 2, 1. Okay, next we want to determine our this dot. Okay, at this dot, 0, 1 times 1 is 1 plus 0 times 1. Okay, this value I forgot to put, it is 1. This is 1, 1 minus g. So the value is 0. So it is 1. Then 1 times 1, 1 plus 0, which is 1. Then 2 times 1, 2 plus 1 times 1 times 1, 1, 3. And then we have 2. Okay, 1 times 1, 1 times minus 1 is minus 1. So we have 1. Okay, next we want to determine capital G0. So 1 times 1, 1 plus 3 times 1, 3 times 1, 3. So you have 4. Okay, G1, 1 times 1, 1 plus, okay, so we have this 1 times minus j times 1 is minus j. So here we have 1 minus j. G2, 1 times 1, 1 plus 3 times 1, 3 times minus 1, minus 3. So we have minus 2. Okay, next G3, 1 times 1, 1. Okay, 1 times minus j, j plus 1 times minus 1 is j plus j. Okay, so we know that our gk is equal to G0 is 4, G1 is 1 minus j, G2 is minus 2, G3 is 1 plus j. So the range is from 0 to k. Alright, you can check with your answer in example 1. Okay, you should get the same answer. Okay, alright. Okay, this is for Gn. Okay, next we do for Hn. Basically, from the question, we know that your Hn is equal to, okay, So basically same thing. First you need to determine your M and you need to determine your R. Okay, so basically from previous we know that your M is 0 and 1. Okay, and then after you get your M, you need to determine your R. Okay, next from the previous again we know that this is our R. Okay, next what we have to do is sketch the line. We sketch the main connectors. Okay, so this is our initial stage. Okay, again is HN. Your output is HK. Okay, next what you have to do is you need to connect the lines. Okay, same thing. We have to put the weight. Okay, so weight is here. So the weight is W40 because of our R equal to 0. So next is also W40. Okay, W40. Another one is W41. So you calculate the value. So W40, the value is 1. W41 is minus T. Okay, so horizontal line that connects to the weight, the value is minus 1. Horizontal lines that connects to the weight, minus 1. Horizontal line that connects to the weight, minus 1. Minus 1. For DIT, FFT, the output will follow the order. Okay, so for input you need to do bit reversal. So for you to do bit reversal, make sure you convert your decimal to binary. Okay, next we want to calculate the value. So H0, so we have 0, 1, 2, 3. So H0 the value is 2, H2 the value is 1, H1 the value is 2, H3 the value is 1. Okay, so you can just put this value here. 2 times 1, 2, 2 times 1, 1 times 1, 1, 2 times 1, 2, 1 times 1, 1. Okay, next we're going to find what is the value of this dot. So 2 times 1 times 1, 2, plus 1 times 1 times 1 is 3. Okay, next 2 times 1, 2. Okay, 1 times 1 times minus 1 is minus 1, so you have 1. So next 2 times 1, 2 times 1 plus 1, so you get 3. 2 plus 1 times 1, 2. 1 times 1 times minus 1 is minus 1, so you get 1. Okay, next H0, 3 times 1. So your HK is equal to 6, 1 minus J, 0, 1 plus J. The range is from 0 to 3. Okay, done. This is just the recap. For chapter 5, what you need to know is, okay, we have two techniques for you to solve finite line sequence. discrete sequence. So forget to put discrete. So basically we have two techniques. One is DFT, discrete Fourier transform. Another one is fast Fourier transform, FFT. So for you to solve DFT, you need to use matrix dimension, matrix computation, calculation. Okay, so basically for you to calculate for the matrix, you must know what is your matrix dimension. But for FFT, you need to use butterfly diagram. Okay, as I explained before, under FFT, we have two types of FFT. One is decimation in time. Another one is decimation in frequency. So, what I have teach you is on DIT FFT. On DIF FFT is actually the reverse structure of DIT FFT. DIF FFT is the reverse structure of DIT FFT. Okay, under DFT, okay, you need to understand on how to compute for endpoint, how to do matrix multiplication on two endpoint. Okay, next is on circular shifting, and then last is on circular convolution. So under circular shifting, we have circular shifting of time domain sequence. Another one is on frequency domain sequence. But for circular convolution, we just have one. So make sure please study on this part also. Alright, so for DIT FFT and DIF FFT, first step you have to identify your capital N value. So how to know your capital N value? It is from length N, endpoint, something like that. Okay, next. Okay, if the question didn't state on the length 4 or 4 point, okay, you can determine the capital N value based on the range, the given range. Okay, next you need to determine M and R. After you determine the number of stages M and R, next you have to sketch your structure. Okay, so for you to sketch the structure, you must know, okay, first, okay, you must have the idea about the structure. Okay, if you were asked to sketch DIT FFT structure, means you have to sketch the structure. It is from many lines to one group. But for DIF FFT, the structure it is from one group to many lines. Okay, this is all about the structure. Okay, next is on weight location. Okay, you need to place your weight. Okay, so at which point? Okay, so for DIT FFT, you have to place the weight at the input node. So which input node? Connect to arrow pointing upwards and horizontal line. But while for DIF FFT, you have to place your WNR at the output node. So which output node? At that output node must connect to arrow pointing downwards and horizontal lines. Okay, that is the difference between DIT FFT and DIF FFT. Another one is on sequence order. Okay, so for DIT FFT, the sequence order, it is from, you need to do bit reversal from output to input. But for DIF FFT, you need to do bit reversal from input to output. Okay, so basically you must know this the difference between them, so for you to sketch the correct structure. Okay, after you sketch the correct structure, then you can determine your output. So what you have to do is you need to do the computation. Alright, so that's all for chapter 5. So if you have any question, don't hesitate to contact me. Alright, so done for chapter 5. So see you later in next chapter. Alright, bye.